Welcome back. This is Mrs. Rubright, and this is Algebra 1 Honors 5.3, Solving Systems by Elimination. All right, so the elimination method is another method used to solve a system of linear equations. In this method, one variable is eliminated by adding or subtracting the two equations of the system to obtain a single equation in one variable. The steps for this method are as follows. You're going to add or subtract the equations to eliminate one variable. In order to do that, you first have to line them up. Then you're going to solve the resulting equation for the other variable. Substitute the value into either of the original equations to find the value of the eliminated variable. This makes more sense once we get into a practice problem. All right, so we are going to solve the system of equations by adding. So these are lined up. Your x's are lined up, your y's are lined up, your equal signs are lined up, and your constants are lined up. So once you do that, you are going to add. So you guys see how you have a negative 2y and a positive 2y, they cancel each other out, which is the whole purpose of elimination, is to get something to cancel out. So when these cancel out, I get 4x plus x is 5x, 12 plus 8 is 20. So I have 5x plus 20. Divide by 5 on both sides, and I get that x equals 4. Okay, x is going to equal 4. So you should have noticed that the negative 2y and the 2y were opposites. That's what you want so that you can eliminate the y variable. Okay? So now once I solve for x, I can plug back into either of the original equations. So they chose this equation. And I'm plugging in a 4 for x. 4 plus 2y equals 8. I'm going to subtract 4 from both sides, giving me 2y equals 4. And I'm going to divide by 2 on both sides, giving me y equals 2. Alright, so I substituted in the 4 for the x. I subtracted the 4 from both sides, and I divided by 2 on both sides. So my solution, if x equals 4 and y equals 2, my solution is 4, 2, the ordered pair 4, 2. That means that the point 42 lies on both lines. We can double check this. We can plug back in. 4 times 4 is 16. 16 minus 2 times 2 is 4. 16 minus 4 is 12. 12 equals 12, so we know we're good. And on the bottom, we had 4 plus 2 times 2 is 4 equals 8. It does, so we know that we are good. So we can always plug back in to check. I'm sure that's probably going to be on the next page. Yes, it is. Okay, so they are checking, though, by graphing, not by plugging back in. All right, so the x-intercept. The x-intercept is when y is 0, so you cover up the y. Divide by 4 on both sides, and you get that the x-intercept is at 3. Your y-intercept is when x is 0, so divide by negative 2 on both sides, and you get that your y-intercept is at negative 6. All right, so our x-intercept is when y is 0, so that's going to be x equals 8. And our y-intercept is when x is 0, divide by 2 on both sides, y is 4. All right, so we have 3 for our x-intercept and our y-intercept of negative 6. Where's my straight edge? I had one here earlier. Okay, and then our next one has an x-intercept of 8 and a y-intercept of 4. All right, so it looks like their intersection is at 4, 2. Get into the elevator over to 4 before you go up to 2. 4, 2, which is the same thing that we got on the previous page. All right, so there's multiple ways to check your work. Can this linear system be solved by subtracting one of the original equations from the other? Why or why not? So, what do you guys think? Can you subtract the original equations? No. If either of the original equations in the system is subtracted, from the other, they won't have a variable eliminated, right? They won't eliminate a variable. What is another way to check your solution? So just like I did, you could substitute. For 2, the answer, the solution, into each equation. To see if they are both true. Okay. Solve the system of equations by subtracting. Check your answer. All right, so we have to subtract because this is a 6 and this is a -1. There's nothing that's going to cancel out here, but these are both a 2. So if I subtract and I distribute a negative, then I would have 2x versus -2x, and I'd have something to be able to eliminate. So if I'm going to distribute this negative, I'm just going to rewrite it off to the side. I don't like how they're doing this. I would have 2x plus 6y equals 6 minus 2x plus y equals +8. I like to do it like this, and then I kind of just always add. I just think it makes more sense in my brain. So then these cancel out, and I have 7y's equals 6 plus 8, 14. Divide by 7 on both sides, y equals 2. I kind of prefer to, subtraction is adding a negative. So I'd rather distribute it out and just add, because to me, then I'm not going to make mistakes, you know? So what they did here, though, is that they both contained the term 2x, and they wanted to eliminate the x variable, and they got y equals 2, okay? Substitute the solution into one of the equations to solve for x, okay? So we're subbing in a 2 for y. We're going to add 2 to both sides, giving us 2x equals -6. We're going to divide by +2 on both sides, giving us x equals -3. So our solution is going to be -3, 2, x, y, right? Let's double check. 2 times -3 is -6. 6 times 2 is 12. -6 plus 12 is 6, so we know we're good. 2 times -3 is -6. Minus 2 is -8, so we are good. So I just quickly substituted it back in to the original 2 equations, and I found out that I did not make any mistakes, that is the solution that satisfies both equations. They once again want to check by graphing. So their x-intercepts when y is 0, divide by 2 on both sides, x is 3. Y-intercepts when x is 0, divide by 6 on both sides, y is 1. So x is 3, y is 1. That's our first line. All right, our x-intercept is when y is 0, so that's going to be -4. Our y-intercept is when x is 0, so that's going to be 8. X is -4, y is 8. And we can see that our intersection is at -1, 2, 3, comma 1, 2. -3, 2. Once again, the same answer of -3, 2. Okay? What would happen if you added the original equations instead of subtracting? You'd get, if you added them, you would have had 4x plus 5y. Nothing would eliminate. You would have 4x plus 5y, so nothing would eliminate. For B, instead of subtracting 2x minus y equals negative 8 from 2x plus 6y equals 6, what equation could you add to get the same result? So to get the same result, you could just add the negative version of this. You could add negative 2x plus y equals positive 8, right? By distributing in a negative to the equation. Because subtraction is adding a negative. How can you decide whether to add or subtract to eliminate a variable in a linear system? Explain your reasoning. You need to make sure that you have opposites, right? So if the equations have two terms that are opposites, you add them. If they are the same, then you subtract or add their negatives. All right, distribute a negative and add. Some linear systems, neither variable can be eliminated by adding or subtracting the equations directly. In systems like these, you need to multiply one or both sides of the equation by a constant so that adding or subtracting the equations will eliminate one variable. The steps for this method are as follows. Decide which variable to eliminate. Multiply one or both equations by a constant so that adding or subtracting will eliminate the variable. Solve the system by the elimination method. So, like here, we have negative y and positive y, so this one actually is going to eliminate very nicely without multiplying. For some reason, they're just deciding not to eliminate the y's, which is kind of annoying in my opinion because these are set up perfectly for elimination. I would literally go like this and be like 3x equals 3, so x equals 1, plug back in, 1 plus what equals 2, subtract 1, y equals 1, and I'm done. And that was like the fastest problem ever, but they decided that using this poor example for this was somehow going to help you guys. I don't know. So what if I said, okay, I don't want you to eliminate the y's, I want you to eliminate the x's. The only way to eliminate the x's is if I take the second equation and multiply it by negative 2 so that I have 2x versus negative 2x. Okay? So that way I would have my equation, my second equation times, they're multiplying it by 2. Okay, that's silly. What are they doing? They want a third equation. Why? What are they doing? They have this is the first equation, and they're doing it with this, but that makes no sense because they don't have opposites. So what I'm going to tell you to do is to cancel out this page because it is all kinds of flawed. Next page. Okay, so down here, example 4. Example 4. Solving a linear system by multiplying one equation. Okay, so this is a good example of what they were saying to do when you have to multiply. Because do you see how there's a 3 and a 2, an 8 and a negative 2? There's nothing that's going to cancel out without us manipulating something. So this one has plus and minus already. So if I multiply the second one by what? So that 8y will cancel out with negative 8y. Multiply it by 4. So I would have 3x plus 8y equals 7. And my second one would be 8x minus 8y equals negative 40. Do you guys see how I did that? I just distributed a 4 to everything on the second one. So now this is set up perfectly for elimination. Those are gone. 11x equals negative 33. Divide by 11 on both sides, x equals -3. You guys see how it makes sense in this example? The other example made no sense what they were doing. But this makes perfect sense. Okay, so now that I have my x, let's plug back in for my y. So I have 3 times -3 plus 8 times y equals 7. -9 plus 8y equals 7. Add 9 to both sides. 16 equals 8y. Divide by 8 on both sides. Y equals 2. So my answer is -3, 2. Let's double check. That'd be -9 plus 16 equals 7. Sure does. That'd be -6 minus 4 equals -10. Bam, bam. Sure does. So we definitely know our solution is -3, 2. Explain how to multiply one of the equations by a number so that the coefficients for one of the variables are opposites. So you can multiply the second equation by 4. So the y's will eliminate. Or will be opposites and eliminate? Alright, so multiply the second equation by the constant you found in part A. So they're literally just showing everything that I just did, right? Pretty much. So we're just going to fill this in just to kind of have our work here. So the x is -3. We already did this. We're just filling in the work for what we did on the previous page. Okay, that's everything that we just did. We just took up a lot less space, right? How can you solve this linear system by subtracting, which is more efficient, adding or subtracting? Explain your reasoning. So you could multiply the second equation by -4 and then subtract. Adding is more efficient because the y terms are already opposite signs. Can this linear system be solved by adding or subtracting without multiplying? Why or why not? No. Because without multiplying, the variables can't be eliminated. What would you need to multiply the second equation by to eliminate x by adding? Eliminate x by adding? You can, I guess you'd have to multiply it by -3 and multiply the top one by 2. Or, I guess if they don't want you to do something to both. So you can multiply it by, you need it to be 3. So how can I make a 2 into a 3? I need it to be a -3, right? So 2 times what equals -3, right? Divide by 2. So I need to multiply it by -3/2, right? You need to multiply by -3/2. Who would do that? Seriously. But if you but that's what they're asking. So I was like, okay, 2 times what is going to give me -3? Well, I have -3/2. So I set up a little equation just to be able to figure that out and wrap my brain around it. All right, so Another example. Solve the system of equations by multiplying. All right, so what can I get to cancel out? 9 and 13, those are not nice. How about 3 and 4? Do you know a number that goes into both 3 and 4? Like 3 and 4 can both multiply into what? 12. So why don't I make these 12? So I can do the top one times 4 and the bottom one times 3, right? So I'd have negative 12x plus 9 times 4, use my trick, 36, y equals negative 12. 12x minus 13, 26, 36, 39, y equals 15. These eliminate. 36 minus 39 is negative 3y equals 3. So y equals negative 1. Plug back in. 4x minus 13 times negative 1 equals 5. 4x plus 13 equals 5. Subtract 13. Negative 8 equals 4x. So x equals negative 2. So let's see. Negative 2, negative 1. That would be 6 minus 9 equals negative 3. Sure does. That'd be negative 8 plus 13 equals 5. Does negative 8 plus 13 equal 5? That'd be 3, 4, 5. Yes, it does. So we know we're good. Explain how to multiply both of the equations by different integers so that the coefficients for one of the variables are opposites. So I'd multiply the top by 4 and the bottom equation by 3. Okay. They're just showing exactly what we just did. Okay, so this is all their work for what we just did. Okay. So, what numbers would you need to multiply both equations by to eliminate y? Why might you choose to eliminate x instead? So, to eliminate y, we had 9 and 13. So, 9, 18, 27. What comes next? 9, 18, 27, 36. That'd be 26. No. What's next? When are they ever going to be the same? I mean, I guess you could multiply this one by 13 and this one by 9. They'll definitely be the same then, right? So, you would multiply the first equation by 13 and the second one by 9. The numbers used to eliminate x are smaller and easier to work with. Describe how to find the numbers by which you would multiply both equations to eliminate a variable. You're finding the least common multiple, right? Of the coefficients. For one variable. Then multiply the equations so that the coefficients for that variable both equal the least common multiple. Or one is the least common multiple and the other is its opposite. If both equations must be multiplied in order to eliminate a variable, how can you decide which variable would be easier to eliminate? The variable with the lower least common multiple. Right? It'll be easier if it's a lower number. All right, so looking at number 1. This is already set up for perfect elimination. Look, gone. 1 minus 3 is negative 2y. Negative 3 plus negative 1 is negative 4. Divide by negative 2 on both sides. Y equals 2. Plug back in. Negative 5x plus 2 equals negative 3. Subtract 2. Negative 5 equals negative 5x. Divide by negative 5. X equals 1. 1 comma 2. Let's plug back in to check. Negative 5 plus 2 equals negative 3. Sure does. 5 minus 6 is negative 1. Yes, it is. 1, 2 is our first solution. I want you guys to quickly try number 3, or actually number 2. Try number 2. The first thing I would do is distribute a negative to the second one, right? Did you guys get negative 2, negative 2? Plug back in. Negative 4 minus 2 or plus negative 2 equals negative 6. Sure does. 10 minus 2 equals 8. Yes, it does. Are we okay on that one? Try number 3. All right, so I got 5, 4. I distributed a negative to the second part. I eliminated. I got y equals 4. And then I plugged back in, and I got that x is 5, right? So then I plugged 5, 4 into both equations, and it worked for both. Was everyone able to get 5, 4? 5, 4? All right, so I want you guys to try one more. How about number 7? So you have 2 and 5 or 2 and 6. Can 2 and 5, can you do something to one thing and make 2 and 5 the same? No. How about 2 and 6? Can you do something to one thing and make them both the same? Yes. The top one you can multiply by 3 because you'd have 6y minus 6y and it would eliminate. So multiply the top one by 3, that's your hint. So your solution should be 3, 4. 3, 4. I multiplied the top one by 3, which gave me negative 6x plus 6y equals 6. I rewrote the second equation. I can see that the 6y and the negative 6y are going to eliminate, leaving me with negative x equals negative 3, so x is 3. Once I know that x is 3, I plug it back into one of the equations. I chose the second one. So then I got that y is 4. Once I had 3, 4, I plugged back into both equations to make sure that they worked, and they did. Are we okay on this lesson? All right, so this was your whole lesson on 5.3, Solving Systems by Elimination. I hope you guys enjoyed the lesson. Please like and subscribe, and have a great day.